हेलो दोस्तों, वेलकम टू द साइनिंग ब्रेन। आज हम एनसीईआरटी की सीरीज़ को आगे बढ़ाते हुए क्लास 7 का चैप्टर नंबर 9 सॉइल को पढ़ेंगे। चलिए स्टार्ट करते हैं। सॉइल इज़ वन ऑफ द मोस्ट इम्पोर्टेंट नेचुरल रिसोर्सेज. इट्स प्रोवाइड encourage to the plants and supplies water and nutrients. It is the home for many organisms. Soil is essential for agriculture. Agriculture provides foods, clothing, and shelters for all. Soil is thus an inseparable part of our body or life. The earthy fragrance of soil after the first rain is always refreshing. 9.1 Soil teeming with life. One day during the rainy season, Paheli and Bozo observed an earthworm coming out of the soil. Paheli wondered whether there were other organisms also in the soil. Let us find out. Collect some soil sample and observe them carefully. You can use a hand lens. Examine each sample carefully and fill in table 9.1. Discuss your observation with your friend. Are the soil samples collected by your friends similar to the ones collected by you? Bojo and Paheli have used soil in many ways. They enjoy playing with it. It is a great fun indeed. Make a list of their uses of soil. Here table 9.1. Ek garden soil, plant, grass, animal and any other observation. I wondered why I found some places of plastic articles or polythene bags in the soil sample collected from the roadside and in the garden. Polythene bags and plastic pollute the soil. They also kill the organism living in the soil. That is why there is a demand to ban the polythene gas and plastics. Other substances which pollute the soil are a number of waste products, chemicals and pesticides. Waste products and chemicals should be treated before they are released into the soil. The use of pesticides should be minimized. Bojo, I have seen pots and toys made up of soil in Hart Bazaar. 9.2 Soil profile. Soil is composed of distinct layers. Perform the following activity to find out how these layers are arranged. Activity 9.2 Take a little soil, break the clumps with your hands to powder it. Now take a glass tumbler, 3/4 filled with water, and then add a handful of soil to it. Stir it well with a stick to dissolve the soil. Now let it stand undisturbed for some time. Figure 9.2. Afterward, observe it and answer the following questions. Figure 9.2 Layer of the soil. Did you see the layer of particles of different size in the glass tumbler? Draw a diagram showing these layers. Are there some dead rotting leaves or animal remains floating on water? The rotting dead matter in the soil is called humus. You probably know that the soil is formed by the breaking down of rocks by the action of wind, water and climate. This process is called weathering. The nature of any soil depends upon the rocks from which it has been formed and the type of vegetation that grows in it. A vertical section through perfect different layer of the soil is called the soil profile. Each layer differs in feel, texture, color, depth and chemical composition. These layers are referred to as horizon. Figure 9.3 A horizon, B horizon, C horizon and bedrock. Figure 9.3 Soil profile. We usually see the top surface of the soil, not the layer below it. If we look at the side of the recently dug ditch, we can see the inner layer of the soil too. Such a view enables us to observe the soil profile at that place. Soil profile can be seen while digging a well or laying the foundation of a building. It can also be seen at the side of a road or a hill or at a steep river bank. The uppermost horizon is generally dark in color as it is rich in humus and minerals. The humus makes the soil fertile and provide nutrients to growing plants. This layer is generally soft, porous, and can contain more water. It is called topsoil or the A horizon. This provides shelter for many living organisms such as worms, rodents, moles, and beetles. The root of some small plants are embedded entirely in the topsoil. The next layer has a lesser amount of humus but more of minerals. This layer is generally harder and more compact and is called the B horizon or the middle layer. The third layer is the C horizon, which is made up of small lumps of rocks which crack and crevice. Below this layer is the bedrock, which is hard and difficult to dig with a spade. 9.3 Soil types. As you know, weathering of soil produces a small particle of various materials. This includes sand and clay. The relative amount of sand and clay depend upon the rock from which the particles were formed. That is the parent rock. The mixture of rock particle and humus is called the soil. Living organisms such as bacteria, plants, roots, and earthworms are also important part of any soil. The soil is classified on the basis of the proportion of particles of various sizes. If soil contains greater proportion of big particle, it is called sandy soil. If the proportion of the fine particle is relatively higher, then it is called clay soil. If the amount of large and fine particle is about the same, then the soil is called loamy. Thus, the soil can be classified as sandy, clay, and loamy. The size of particle in a soil has an influence on its property. Sand particles are quite large. They cannot fit close together, so there are large spaces between them. These spaces are filled with air. We say that the sand is very aerated. Water can drain quickly through the space between the sand particles, so sandy soil tends to be light, well aerated, and rather dry. Clay particles, being much smaller, pack tightly together, leaving little space for air. Unlike sandy soil, water can be held in the teeny gaps between the particles of clay. So clay soils have less air, but they are heavy as they hold more water than the sandy soil. The best topsoil for growing plants is loam. Loamy soil is a mixture of sand, clay, and another type of soil particle known as silt. Silt occur as a deposit in river beds. The size of the silt particle is between those of sand and clay. The loamy soil also has humus in it. It has the right water holding capacity for the growth of plant. Bojo, I want to know what kind of soil should be used for making earthen pots, matkas, and surahis. Activity 9.3. Collect sample of clay, loamy, and sandy soils. Take a fistful of soil from one of the sample. Remove any pebbles, rocks, or grass blades from it. Now add water drop by drop and knead the soil. Add just enough water so that a ball, figure 9.4b, can be made from it, but at the same time it would not be sticky. Try to make a ball, figure 9.4c, from this soil on a flat source. Roll this ball into a cylinder, figure 9.4d. Try to make a ring from this cylinder, figure 9.4e. Repeat this activity with other sample also. Does the extent to which a soil can be shaped indicate its type? Can you suggest which type of soil would be the best for making pots, toys, and statues? This is the figure of 9.4 A, B, C, D, E. Working with the soil. 9.4 Properties of soil. You have listed some uses of the soil. Let us perform some activities to find the characteristics of the soil. Percolation rate of water in soil. Bozo and Paheli marked two different square 50 into 50 cm each. One of the floor of their house and the other on the kacha unpaved road. They filled two bottles of the same size with water. They emptied the water from the bottles, one each at the same time in the two squares. They observed that the water on the floor flowed down and was not absorbed on the kacha road. On the other hand, the water was absorbed. Now let us perform an activity to understand this. Bojo wondered why there was a difference in the absorption of water in the two squares. Activity 9.4. For this activity, divide yourself into three teams. Name the team A, B and C. You will be finding out how fast the water passes down the soil. You will need a hollow cylinder or a pipe. Ensure that each them uses pipe of the same diameter. Some suggestions for obtaining such a pipe are given below. If possible, get a small tin can and cut off its bottom. If PVC pipe approx diameter 5 cm is available, cut it into 20 cm long pieces and use them. At the place where you collect the soil, place the pipe about 2 cm deep in the ground. Pour 200 ml water in the pipe slowly. For measuring 200 ml water, you can use any empty 200 ml bottle. Note the time when you start pouring water. When all the water has percolated, leaving the pipe empty, note the time again. Be careful not to let the water spill over or run down on the outside of the pipe while pouring. Calculate the rate of percolation by using the following formula. Percolation rate, milliliter per minute. Amount of water in milliliter divided by percolation time in minute. For example, suppose that for a certain sample it took 20 minutes for 200 milliliter to percolate, so the rate of percolation 200 milliliter by 20 and 10 milliliter per minute. Calculate the rate of percolation in your soil sample. Compare your finding with other and arrange the soil sample in the increasing order of the rate of percolation. 9.5. Moisture in soil. Have you ever passed through a farmland during a hot summer day? Perhaps you noticed that the air above the land is simmering. Why is it so? Try out the activity and find the answer. Activity 9.5. Take a boiling tube, put 2 spoonfuls of a soil sample in it. Heat it on a flame, figure 9.6, and absorb it. Let us find out what happened upon heating. Do you see water drops anywhere? If yes, where did you find them? On heating, water in the soil evaporates, moves up and condenses on the cooler inner wall of the water part of the boiling tube. On a hot summer day, the vapor coming out of the soil reflects the sunlight and the air above the soil seems to simmer. This is the figure 9.6, removing moisture from the soil. After heating the soil, take it out of the tube. Compare it with the soil which has not been heated. Note the difference between the two. 9.6. Absorption of water by soil. Do all the soil absorb water to the same extent? Let us find out. Activity 9.6. Take a plastic funnel, take a filter paper or a piece of newspaper sheet, fold and place it as shown in figure 9.7. Weigh 50 grams of dry powdered soil and pour it into the funnel. Measuring a certain amount of water in a measuring cylinder and pour it drop by drop on the soil. You can use a dropper for this purpose. Do not let all the water fall on one shot. Pour water all over the soil. Keep pouring water till it starts dripping. Figure 9.7. Absorption of water in the soil. Here one shows dropper, filter paper, funnel and beaker. Subtract the amount of water left in the measuring cylinder from the amount you started with. This is the amount of water retained by the soil. Record your results in your notebook in the following manners. Weight of soil equal to 50 gram. Initial volume of water in the measuring cylinder U milliliter. Final volume of the water in the measuring cylinder V milliliter. Volume of water absorbed by the soil U minus V milliliter. Weight of water absorbed by the soil U minus V gram. 1 milliliter of water has weight equal to 1 gram. Grams and kilogram are actually unit of mass. A mass of 1 gram weigh 1 gram weight, and a mass of 1 kilogram weigh 1 kilogram weight. However, in daily life and in commerce and industry, the distinction between gram and gram weight is generally omitted. Percentage of water absorbed equal to U minus V by 50 into 100. Repeat this activity with different soil sample. Would you get the same result for all the samples? Discuss the result with your friends and answer the following question. Which soil would have the highest percolation rate? Which soil would have the lowest percolation rate? Bojo heard from his neighbor that 8 to 10 days after the rain, the level of water in a ponds of well rises. Which type of soil will allow water to reach a well faster and in greater amount? Which type of soil retain the highest amount of water and which retain the least? Can you suggest any method to let more rainwater percolate and reaches the water underground? 9.7 Soil and crops. Different type of soils are found in different part of India. In some parts there is clay soil, in some part there is loamy soil, while in some other part there is sandy soil. Soil is affected by wind, rainfall, temperature, light, humidities. These are some important climatic factors which affect the soil profile and bring change in the soil structure. The climatic factor as well as the component of soil determine the various type of vegetation and crops that might grow in any region. Clay and loamy soil are both suitable for growing cereals like wheat and gram. Such soil are good at retaining water. For paddy soil rich in clay and organic matter are having a good capacity to retain water are ideal. For lentils, masoor and other pulses, loamy soil which drain water easily are required. For cotton, sandy loam or loam which drain water easily. Here a case study is given. John, Rasida and Radha went to the Liladhar Dada and Santosh Malviya of Sohagpur in Madhya Pradesh. Liladhar Dada was preparing the soil to make items like surahi, matki, kala, earthen frying pan, etc. The following is the conversation they all had with Liladhar Dada. Where was the soil obtained from? Dada: we brought the black soil from a piece of barren land. How is the soil prepared? Dada: dry soil will be placed in a large tank and would be cleaned of pebbles, etc. After removing these things, the soil will be soaked for around 8 hours. This soil would be needed after mixing horse dung. The kneaded soil would be placed on the wheel and given a approximate shape. The final shape is given with hands. The items are colored after 3 days of drying. All the items are baked at the high temperature after drying in the air. Why is the horse dung mixed in the soil? Dada: burnt horse dung helps open up the pores in the soil, so that water could percolate out of the matkas and surahi, evaporates and cool the water inside. You know, Sohag Puri, Surahi and matkas are famous in far-off places like Jabalpur, Nagpur, Prayagraj, erstwhile Allahabad, etc. Now we are continuing this. For cotton, sandy loam or loam which drain water easily and can hold plenty of air are more suitable. Crops such as wheat are grown in the fine clay soil because they are rich in humus and are very fertile. Find from your teacher, parents and farmers the type of soils and crops grown in your area. Enter the data in the following table 9.2. Which kind of soil would be most suitable for planting rice? Soil which a higher or lower rate of percolation. Table 9.2. What is the difference between the rate of percolation and the amount of water retained? Bojo, you seem to have forgotten what you read earlier. Go and reread the lesson again and you will find the answer. Soil erosion. The removal of land surface by water, wind or ice is known as erosion. Plant roots firmly bind the soil. In the absence of plants, soil becomes loose so it can move by wind and flowing water. Erosion of the soil is more severe in area of little or no surface vegetation, such as desert or bare land. So, cutting of trees and deforestation should be prevented and efforts should be made to increase the green area. Here the keywords are clay, moisture, humus, sandy, loamy, water retention, percolation. दिस इज़ द एंड ऑफ द चैप्टर नंबर 9. अगले पार्ट में हम चैप्टर नंबर 10 के बारे में पढ़ेंगे. तब तक के लिए धन्यवाद.